This is mathheals.com, where you can find more links to math YouTube videos and computer science. Let's take a look at linear inequalities in two variables. First two are the oddball cases, so let's talk about those first. Get my little tablet straightened out there. There we go. We got y is greater than 3. In general, on any of these problems where you have a greater than or less than, it's going to be a dotted line. If you have a greater than or equal to or less than or equal to, it'll be a solid line. So on this one, if we pretend the inequality is an equals, we're looking at y is equal to 3. We're going to graph that first. Well, y is equal to 3 is a horizontal line at 3. Now it's a greater than, so greater than is a dotted line. So it goes across like that. Now y is greater than 3. Well, if it's greater than, we shade above it. If it was less than, then we'd shade below it. And that's our answer. Now what makes this one an oddball one, and it actually makes it easier, is it only has one variable. Title of this section is Linear Inequalities in Two Variables. Well, this next one's also an oddball one. We got x is less than or equal to negative 2. Well, if we pretended that inequality was an equals, we'd have x is equal to negative 2, which means it would be a vertical line at negative 2. Let me write that a little bit more legible. So we're going to have a vertical line at negative 2, and it's less than or equal to, which means we're going to have a solid line. Like that. Now, since it's less than, that means we shade to the left. If it was greater than, we'd shade to the right of that line. And that would be your answer. Well, this one I'm going to show two different ways. I'm going to show it by hand, then I'll show it on the calculator. Okay. Now, our first step. And this is graphing inequality in two variables. Our first step is pretend the inequality symbol is an equals and graph it. With the stipulation of what we set up above, that if you have a less than or greater than, that's a dotted line. If we have a less than or equal to or greater than or equal to, that's a solid line. Well, let's come over here. If I pretended this was y is equal to negative 4x plus 2, our y-intercept would be 2. So I'm going to come here and put a dot at 2. Our slope, this is in slope-intercept form. So this is our y-intercept, and our slope is the number that's before x, which is negative 4. And I want to write it in fraction form. Now remember, this is a change in y over change in x, so this is down 4, right 1. So down 4, 2, 3, 4, right 1, and that would be our second point. Now specifically, this is a less than, which means we want a dotted line. So when you do this line, it's going to be a dotted line, like that. What we're going to do then is we're going to pick a test point and plug it into our inequality. So plug it into our inequality. If true, then shade decide where the point falls. If it's false, shade the other side. Now, almost your perfect one to pick will be your origin, unless you can't tell which side your origin falls on. Well, here's our origin right here. That's 0, 0. So we're going to choose, for this particular problem, 0, 0. It does not matter which point you pick. Now we want to plug that into our inequality. Our inequality is y is less than negative 4x plus 2. And let me put it over here. So we'll put 0 in for the y, is less than negative 4, and we'll put 0 in for the x, and then plus 2. Now this is not a less than at this point, this is a question mark. We're wondering if that's true. Well, negative 4 times 0 is 0, plus 2 is 2. Is 0 less than 2? Yeah, it is. So this is true. Well, this says if it's true, then you shade decide where the point falls. Well, our point fell on this side. We're talking about which side of the dotted line here. So there's this side, and then there's the other side. Since it fell on this side, and this is true, then it says shade decide where the point falls. So we'll shade that right there. And that's our answer. Now to do this on the calculator, we've got y is less than negative 4x plus 2. If you have a less than or a less than or equal to, we'll have a lower left-hand triangle. If you have a greater than or greater than or equal to, you'll have an upper right-hand triangle. Like this. Well, let's go plug in negative 4x plus 2 in our calculator. So press my y equals, press clear, negative 4x plus 2. Now look where my cursor is. I'm going to press my left arrow key until my flashing cursor is on this first slash, clear over to the far left. You can't do it too many times. Once your cursor is there, if you press enter one time, it'll become a thick slash. If you press it one more time, it becomes an upper right-hand triangle. Now this problem is a less than, and we're looking for a lower left-hand triangle. So we press enter one more time, and it changes to a lower left-hand triangle. And then we press graph, and that gives us our answer. The only thing it doesn't give you is whether this line that separates the shaded region from the non-shaded region is dotted or solid. That's what you have to use this note right here. Less than or greater than is a dotted line, less than or equal to or greater than or equal to is a solid line. Let's look at our next problem. I'll first do it by hand, and then I'll use the calculator. Okay, now to do it by hand or a calculator, it's really best to have y by itself on the left side. So I'm going to take the negative 2x and move it to the right side. Anytime you move anything across your inequality symbol, the sign changes, so it becomes a negative. The negative 2x becomes a positive 2x. And we got this. Okay, our first step, we're going to pretend it's y is equal to 2x minus 3 and graph it. Well, negative 3. That would be our y-intercept. Remember, if it's in slope-intercept form, which is what this is, where you got y by itself, then your number is your y-intercept. Your slope is the number that's before your x, which is 2, and I want to write it in fraction form. Since it's a positive 2, it means we'll go up 2, and a positive 1 down here means we go right 1. So we go up 2, right 1, and that's where our second point goes. Now it's a greater than or equal to, which means this is a solid line. Like that. And we want to pick a test case. Again, 0, 0 is your perfect one, if you can tell which side it falls on. And we're going to plug that into our inequality. I'm going to plug it into this one right here. So we've got y is greater than or equal to 2x minus 3. Not that it matters, but this is a little simplified form, I think. So we'll put 0 in for y. This is no longer greater than or equal to, it's a question mark. We're wondering if that's true. Put 0 in for x minus 3. Well, 2 times 0 is 0, minus 3 is negative 3. 0 is greater than or equal to negative 3. Well, it's not equal to, but is it greater than negative 3? Yeah, it is. So that's true. Since it's true, we're going to decide where this point falls. 0, 0 falls right here. So we're going to shade that side. Okay. Plugging this in the calculator. And if I press y equals, press clear. Now you notice when I press clear there, it didn't reset this. That doesn't, on the newer TID4s, it does not reset your shading over there, which is kind of a pain. Let's see, what do we have here? 2x minus 3. I'm going to go over to the left, clear over, till my flashing cursor's on that. Now, if we were completely done, which I'll show this at the end, we'd want to reset it back to the slash. Now, since this is a greater than or equal to, we want an upper right-hand triangle. Well, unfortunately, this is a lower left, so I'm going to press enter one time. Changes this. Enter one more time. Changes that. One more time, dotted line. One more time, my slash. One more time, the fixed slash. One more time, the upper right-hand triangle. Okay. Now we got our upper right-hand triangle because it's a greater than or greater than equal to. We'll press graph. The only thing it doesn't give you is whether this line that separates it is solid or dotted. And again, you have to look at I've erased it, but if it's a less than or equal to or greater than or equal to, it's solid. If it's a less than or greater than, it's dotted. Now, some people that teach this topic in math, they don't really understand how to work the problems, unfortunately. Every semester I run across students that are told by a math teacher, or math teachers I should say, that if it's a greater than or greater than or equal to, you shade to the right. Take a look at this problem. It's a greater than or equal to. So it looks like we're shading to the right. There is a way to explain that. I don't do these by hand enough to really know the little trick to it. I would just pick a test case. Then you don't have to think about it too hard. But it's not what people say, where they say it's always shaded to the right. Okay, let's look at this one. And let me grab a drink here. I'm dying. I'm making these videos, my voice gets so dry, or my throat gets so dry. Minus 4/3 y is less than or equal to 1. Well, it's best to have it in the form of y and then less than or greater than or whatever. The reason why is because that upper right-hand triangle, lower left-hand triangle, that's based upon the y being on the left side. And so on this one, our first step is there's no parentheses, so we'll give her fractions. We got two denominators, 2 and 3, so our LCM of 2 and 3 is 6. So I'm going to multiply everything by 6. Well, 6 and 2 both divisible by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. 3 and 6 both divisible by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. 3 times 1 is 3x minus 2 times 4, that's 8y. It's less than or equal to 6. Now I'm going to take the 3x over to the right side. And I got negative 8y is less than or equal to negative 3x plus 6. Anytime you take anything across your inequality, the sign changes. Now we're trying to get to y by itself, so we're going to divide both sides by the number in front of our y, which is a negative 8. Now when you divide by a negative number, you flip your inequality symbol, so this becomes a greater than or equal to. So that gives us y is greater than or equal to 3/8 x minus 6 and 8 are both divisible by 2, so that gives us 3/4. Okay. We're going to pretend that it's y is equal to 3/8 x minus 3/4 and graph it. Well, if it's in slope-intercept form, the number at the end is your y-intercept. So it's negative 3/4, which would be right there. Okay, our slope is a number that's before x, which is 3/8. Change in y over change in x. This means we're going to go up 3, and we'll go right 8. So up 3, 1, 2, 3, and right 8. I think I put 8 of them down there. Would be 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Would be right here. Now, it's a greater than or equal to, which means this is a solid line. Okay, now we want to pick a test case. And again, unless your line passes right through it, always pick the origin. Don't make your life hard. It'll work on any point, though. I could pick 2, 1. I could pick 5, 7, 100, 99. But 0, 0 is so easy. Okay, so let's plug that into our inequality. So we've got y is greater than or equal to 3/8 x minus 3/4. Put 0 in for y. This is not a greater than or equal to anymore. It's a question mark. We're wondering if that's true. And then 3/8 times 0 minus 3/4. Well, 3/8 times 0 drops away. Unfortunately, every one I've picked here has been true. But if it wasn't true, like if this was false, then we would shade the other side. 0 is greater than negative 3/4. So this is true, which means we'll shade the side where the point falls. So that'd be our answer. Now on a calculator, the point where I get y by itself, that's where I want to plug it in. So let's go put that in. I'll press y equals, press clear. We got 3/8 x, so 3 divided by 8 x minus 3 divided by 4. I want to do my left arrow key. I can't do it no more. It's a greater than or equal to, which means we're looking for an upper right hand triangle. Actually, that's what we have, upper right hand triangle. So that's good as is. And then I'll push graph. And it gives us the same graph as that. Okay, now I told you I was going to show you how to fix your calculator back to normal if it doesn't reset itself. If you come back to y equals and you press clear on this. If you don't see this as a slash now, press your left arrow key and go clear over there. And press enter, enter, and keep pressing enter until it becomes the normal slash. Now that's not the normal slash here, that's a dotted slash. So press one more time, and then I'll right arrow over, and now you're back to the regular mode. I don't know why they broke that on the newer versions of the TI-84 that are coming out. It's kind of a pain. I like that when you press clear, it reset everything. But unfortunately, change happens. Let me save this.